The morning of March 14, 1944, Erprobungsstelle Rechlin, Mecklenburg-Vorpommern, Germany. The train, carrying crate number RLM/4793, had travelled nearly 300 miles from a crash site near Brandenburg, its cargo secured beneath canvas tarps and guarded by Luftwaffe technical personnel who understood that what lay inside represented something far more troubling than a mere downed enemy aircraft. Inside that crate was a P-51 Mustang. The fighter had been shot down 6 days earlier during an American escort mission that, according to every calculation performed by Luftwaffe intelligence, should never have been possible. The pilot had not survived, but the airframe remained largely intact. Enough of it, at least, to provide German engineers with their first complete opportunity to examine the aircraft that was systematically dismantling every assumption the Reich had made about American fighter capabilities. Hauptmann Hermann von Bombach supervised the initial uncrating at Rechlin, Germany's primary aircraft testing and evaluation center. The facility sprawled across the countryside near Lake Müritz, approximately 100 kilometers northwest of Berlin. Here, teams of engineers and test pilots worked methodically to understand every technical advantage the Allies possessed. Von Bombach, who oversaw aircraft development and would later command Test Command South, approached this particular examination with the professional detachment required of Luftwaffe technical staff. But even he could not ignore what the navigation chart still clipped inside the cockpit revealed. The route was marked clearly: Debden, England to Berlin, and back, a round trip exceeding 1,100 miles. This was impossible. Or it should have been. German intelligence assessments, built on rigorous analysis of earlier captured American fighters, had established clear parameters for enemy capabilities. Single-engine fighters lacked sufficient range to escort bombers to Berlin. The mathematics were straightforward and unforgiving. The distance from English bases to the German capital measured approximately 560 miles one way. Standard fighter aircraft, even equipped with external fuel tanks, could not carry enough aviation gasoline for such a mission while maintaining combat capability. The fuel would be exhausted before reaching the target, leaving the pilot with two choices: turn back or die. These assessments had been based on thorough examination of captured P-47 Thunderbolts and P-38 Lightnings. Both aircraft had demonstrated clear limitations. The Thunderbolt, despite its robust construction and powerful engine, showed limited penetration capability into German airspace before fuel constraints forced withdrawal. The Lightning, with its twin engines and distinctive twin-boom design, offered better range, but remained operationally constrained by fuel capacity. Neither aircraft could reach Berlin with sufficient reserves for combat operations and safe return. The events of early March had shattered these comfortable assumptions. On March 4th, P-51 Mustangs from the 4th Fighter Group had escorted a small bomber force to Berlin. It was their first mission in the new aircraft after transitioning from P-47 seconds just days earlier. Weather problems and communication difficulties had limited the mission's effectiveness. Only 32 bombers reached the target, but the tactical success or failure of that particular raid was irrelevant compared to the strategic revelation it represented. American single-engine fighters had reached Berlin, engaged in combat with Luftwaffe interceptors, and returned safely to England. 2 days later, on March 6th, approximately 660 heavy bombers attacked Berlin in broad daylight. Over 150 P-51 Mustangs escorted them, along with P-38 Lightning and P-47 Thunderbolt groups. The American fighters engaged Luftwaffe interceptors directly over the German capital, fought for control of the airspace, and accompanied the bombers home. This was not a fluke. This was not a desperate one-time penetration raid where pilots accepted fuel exhaustion as the price of reaching the target. The Americans had solved the escort fighter problem. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. General Major Adolf Galland, General der Jagdflieger and one of Germany's most decorated fighter aces with over 100 confirmed victories, had personally encountered P-51 formations over Germany during this period. Despite holding administrative responsibilities that should have kept him behind a desk, Galland had flown combat missions to understand firsthand what his pilots faced. He was not a man given to exaggeration or panic. His combat assessments, submitted through official channels, noted something deeply troubling. The American fighters were operating at full combat capability over Berlin. They engaged aggressively. They showed no apparent fuel conservation behavior. They fought with the tactical flexibility of aircraft operating well within their operational radius, not at the extreme limits of their range. They had reserves. This directly contradicted everything Luftwaffe intelligence believed about American fighter capabilities. Galland's reports emphasized additional concerns. The P-51 demonstrated superior performance at high altitude, outmatching both the Messerschmitt Bf 109 and Focke-Wulf TAV 190 in speed and maneuverability above 20,000 feet. This altitude advantage was particularly significant because American bomber formations typically operated between 25,000 and 30,000 feet, where defensive fire from closely spaced bombers remained effective, but German interceptors struggled with reduced engine performance. The technical examination at Rechlin focused immediately on determining how the Americans had achieved this impossible range. The evaluation team, led by experienced engineers who had analyzed dozens of captured Allied aircraft, began with the fundamentals: fuel capacity and consumption. The P-51B's internal fuel system was measured with precision. The aircraft featured 2 wing tanks, each holding 92 gallons of aviation fuel, for a total of 184 gallons in the wings. Additionally, the fuselage contained an 85-gallon fuel tank positioned directly behind the cockpit. This fuselage tank had been incorporated during production specifically to extend range, representing a relatively recent modification to the basic design. Total internal fuel capacity: 269 gallons. The Packard-built Merlin engine represented a significant technical achievement. It was a license-produced version of the Rolls-Royce Merlin that had transformed the Mustang from a capable low-altitude fighter into a high-altitude Escort capable of matching German fighters in the thin air above 25,000 feet. The engine's 2-stage, 2-speed supercharger with intercooler maintained power output at altitudes where single-stage German engines gasped for air. But supercharger technology was irrelevant if the aircraft lacked fuel to reach the target. German engineers performed careful calculations using documented fuel consumption rates. At economy cruise settings, the Packard Merlin burned approximately 60 gallons per hour. At normal cruise power, consumption increased to approximately 75 gallons per hour. Combat power settings, required for dogfighting and high-speed maneuvering, consumed fuel at rates exceeding 100 gallons per hour. The mathematics were straightforward. With 269 gallons of internal fuel and consumption, averaging approximately 70 gallons per hour at cruise settings, the P-51B could remain airborne for roughly 3.8 hours. At the aircraft's cruising speed of approximately 300 miles per hour, this yielded a maximum range of approximately 1,140 miles. This was precisely enough to reach Berlin from English bases and return. Barely. With no reserves for combat operations. With no allowance for headwinds. With no margin for navigation, errors, or tactical maneuvering. Yet combat reports indicated clearly that American fighters had engaged in prolonged dogfights over Berlin. Engagements lasting 15 to 20 minutes were common before the American pilots disengaged and flew home. Combat power settings during those 15 minutes would have consumed approximately 25 gallons. This fuel expenditure should have left the aircraft unable to complete the return journey. Pilots should have been forced to bail out over occupied territory or attempt emergency landings in the North Sea. The calculations did not explain what German pilots were observing in actual combat. The answer revealed itself when technical staff examined the P-51B's wing structure more carefully. The aircraft featured standardized hardpoints under each wing designed to accommodate external stores. These attachment points included fuel line connections and quick-release mechanisms. The purpose was immediately clear to engineers familiar with auxiliary fuel systems. Drop tanks. External fuel tanks were not a revolutionary concept. German fighters had employed them since the Battle of Britain. The Bf 109, could carry a 300-litre drop tank for extended range missions. The W-190 regularly used them when operational requirements demanded greater endurance. The principle was simple and widely understood. Carry additional fuel externally, burn that fuel first during the cruise portion of the mission, then jettison the empty tanks before entering combat to reduce weight and drag. The question was not whether the Americans were using drop tanks. The question was what capacity those tanks possessed and how the Americans were producing them in sufficient quantities to maintain operational tempo across multiple fighter groups conducting daily missions. Intelligence officers at Rechlin began coordinating immediate search operations. They plotted likely jettison points based on engagement locations reported by Luftwaffe pilots during the March missions. Drop tanks would typically be released when enemy fighters were encountered, as the external stores significantly reduced maneuverability and speed. Carrying them into a dogfight was tactical suicide. Search teams composed of Wehrmacht personnel and Hitlerjugend volunteers spread across the countryside northeast of Berlin, looking for debris from the air battles. Within 3 days, several objects were recovered from fields and forests in the region. Most arrived at Rechlin in fragmentary condition, crushed on impact or damaged by the fall from altitude. But 2 examples survived intact, having landed in soft soil or winter wheat fields that cushioned their impact. What arrived at Rechlin revolutionized German understanding of American industrial methods in ways that transcended mere technical specifications. The captured drop tanks were cylindrical, measuring approximately 108 inches in length, with a diameter of roughly 22 inches at the widest point. Capacity calculations indicated each tank held approximately 108 US gallons. 2 such tanks would provide 216 additional gallons of fuel, extending the P-51's total fuel capacity from 269 gallons to 485 gallons. With this fuel load, the Mustang could fly for approximately 6.7 hours at cruise power settings. This yielded a maximum range exceeding 2,000 miles, more than sufficient for the Berlin mission with substantial reserves for combat, operations, tactical maneuvering, and safe return with fuel remaining. The fuel capacity mathematics finally made sense. The impossible had become merely difficult. But what captured the immediate attention of German engineers was not the capacity of the tanks, it was their construction. The drop tanks were not made of metal. Running a hand along the surface revealed a texture unlike aluminum or steel. The silver paint coating the exterior could not disguise the fundamental nature of the material beneath. When engineers carefully scraped away a small section of paint near the tail cone, they discovered what lay under that reflective finish. Paper. Multiple layers of heavy craft paper, each layer perhaps half a millimeter thick, compressed and laminated together with a resinous adhesive. The construction was sophisticated and purposeful. The nose cone and tail cone were formed from overlapping pieces of paper material, pressed into shape using techniques reminiscent of papier-mâché. Each piece was visible as a slight ridge where it overlapped with adjacent pieces, creating a subtle scalloped texture across the surface. The center section was seamless, wrapped around a cylindrical form in continuous layers that showed no joints or seams. The fuel fittings were brass, precisely machined and properly sealed against leakage. Peering through the filler cap revealed an interior coated with what appeared to be a cellulose-based lacquer designed to resist the corrosive effects of aviation gasoline. German materials specialists were brought in immediately to analyze the tank's construction in exhaustive detail. The paper was identified as kraft paper, manufactured using a chemical pulping process that produced exceptionally strong cellulose fibers. This was identical to the material used for heavy-duty shipping containers and industrial packaging throughout the world. The adhesive proved to be a resorcinol formaldehyde resin, a thermosetting polymer that created bonds, stronger than the paper itself when heat-cured under pressure. The lamination involved at least 12 separate layers of paper, each one carefully oriented to provide strength in multiple directions. Anti-slosh baffles made from thin wood were installed inside to prevent fuel from surging during maneuvers, which could destabilize the aircraft. The entire construction process was clearly standardized and designed for mass production using relatively simple manufacturing equipment. Most significantly, The empty tank weighed approximately 80 pounds, compared to 65 to 75 pounds for a comparable metal tank of smaller capacity. The paper construction was not significantly lighter than metal. Weight reduction was not the advantage. The implications became immediately clear to the technical staff at Rechlin, and those implications were profoundly troubling. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins did not require aluminum, steel, or other metals that were increasingly scarce in wartime economies. The manufacturing process required no specialized metalwork equipment, no skilled metalworkers trained in aircraft construction, no welding or precision forming of sheet metal. These tanks could be produced in any paper mill or packaging factory with relatively simple modifications to existing equipment. The United States had hundreds of such facilities distributed across the country, far beyond the range of any German bomber. If even a small percentage of American paper production capacity had been converted to drop tank manufacturing, output could easily reach thousands of units per week. The tanks appeared to have no serial numbers, no manufacturer markings, nothing to indicate limited production runs. They were commodity items, mass-produced and completely expendable. Intelligence officers began researching American paper industry capacity using pre-war industrial statistics and captured documents. The United States produced approximately 12 million tons of paper annually before the war, with production increasing during wartime mobilization to support military requirements. Converting even 1% of this capacity to drop tank production would yield over 100,000 tanks per month, far exceeding any plausible requirement for P-51 operations across all theaters. The real constraint would not be materials or manufacturing capacity. The constraint would be the availability of assembly equipment and labor to construct the tanks. But this was precisely the type of manufacturing that could be performed by semi-skilled workers after minimal training. No apprenticeships required, no years of experience needed, just workers following standardized procedures in factories that had been producing cardboard boxes the previous year. The paper tanks represented industrial efficiency and resource optimization on a scale that German planners found genuinely difficult to comprehend. Further analysis revealed additional details about the tank's design philosophy and operational use. The tanks were strictly single-use items by design. The resorcinol adhesive, while creating strong bonds when properly cured, was slowly dissolved by prolonged contact with aviation gasoline. Intelligence reports and interrogation of captured American aircrew confirmed that paper tanks had to be filled immediately before flight and could not be stored filled for more than a few hours without developing leaks. This limitation did not affect operational use in any meaningful way. Fighters were fueled as part of pre-flight preparation. The tanks would be used for a few hours during the mission, providing the range extension needed to reach deep targets, then jettisoned when empty or when combat was imminent. The single-use nature actually simplified logistics significantly. There was no need to recover and reuse the tanks, no need for cleaning, inspection, or maintenance between missions. They were expendable by design, manufactured in such vast quantities that recovery was unnecessary. The German evaluation noted the color coding of the tanks. Paper drop tanks were painted silver, while metal tanks used by American forces were painted gray. This color distinction allowed ground crews to quickly identify tank types during fueling operations, preventing errors that could compromise missions. The silver finish on paper tanks also helped reflect solar heat, reducing fuel evaporation and vapor pressure issues at high altitude, where temperatures dropped dramatically. Every aspect of the design reflected systematic engineering optimization for mass production and field use. Someone had thought through every detail with the operational realities of fighter escort missions clearly in mind. By late March 1944, German intelligence had traced the origin of the paper drop tanks to British development efforts. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943 to conserve strategic metals, particularly aluminum, for aircraft construction. The Escort Corporation, utilizing expertise in paper manufacturing accumulated over decades of civilian production, had developed the production process and manufacturing techniques. The tanks entered service with RAF fighter squadrons in late 1943. American forces quickly adopted the British design, with multiple manufacturers in both Britain and the United States producing tanks for use by USAAF fighter groups. The innovation had been driven by British resource scarcity and material rationing, but was being exploited on a massive industrial scale by American manufacturing capacity that operated under no such constraints. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The broader implications extended far beyond fuel tanks. German technical staff began a systematic review of captured American equipment, looking for other examples of industrial innovation and mass production techniques. The results painted a remarkably consistent picture across every category examined. American equipment was not always technologically superior to German equivalents in terms of individual component performance. German optics were generally better, offering superior clarity and light transmission. German small arms were often more sophisticated in design, incorporating advanced features and refined mechanisms. German armor metallurgy was, in some respects, more advanced, utilizing specialized alloys and heat treatments. But American equipment was consistently better manufactured, more thoroughly standardized, more operationally reliable, and available in vastly greater quantities than German equivalents. The American approach prioritized producibility over perfection. Components were designed, from the outset for mass production, by semi-skilled workers using standardized tooling and simplified assembly procedures. Parts were genuinely interchangeable between units without hand-fitting or adjustment. Assembly line methods reduced production time per unit and dramatically increased output. Quality control focused on maintaining consistent standards rather than achieving individual perfection. The contrast with German production methods was stark, and, to German engineers familiar with traditional manufacturing philosophy, somewhat disturbing. German weapons and equipment were often technical masterpieces, hand-fitted by skilled craftsmen who took justifiable pride in their work. A German tank or aircraft engine represented the pinnacle of precision engineering, with components manufactured to extraordinarily tight tolerances and assembled with meticulous attention to detail. But building such equipment required highly skilled labor, specialized precision tools, and significant time investment per unit. Production rates were fundamentally constrained by the availability of master craftsmen and precision manufacturing equipment. The Germans built superior individual items, achieving performance levels that American mass production could not match. The Americans built adequate items in overwhelming quantity, achieving production volumes that German craftsmanship could not hope to approach. In industrial warfare waged across continents for years, quantity had proven strategically decisive. Analysis of P-51 Mustang production illustrated this principle with uncomfortable clarity. North American Aviation had designed the original Mustang prototype in response to a British Purchasing Commission requirement in 1940. The prototype, designated NA-73X, was completed just 117 days after the contract was signed. This represented one of the fastest design-to-prototype cycles in aviation history, achieved through pragmatic engineering, decisions and acceptance of good enough solutions, rather than pursuit of theoretical perfection. The first flight occurred on October 26, 1940. By 1944, North American was producing P-51 variants at 2 facilities operating at maximum capacity. The Inglewood plant in California averaged approximately 364 Mustangs per month during peak production periods. The Dallas plant contributed additional production capacity. Combined output across both facilities reached an average of approximately 574 P-51 seconds per month during 1944, with production accelerating throughout the year as manufacturing processes were refined and bottlenecks eliminated. Peak monthly production would reach 881 aircraft in January 1945. Each P-51 required approximately 15,000 individual parts, manufactured by hundreds of subcontractors distributed across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. Final assembly of a P-51D required approximately 22,000 man-hours of total labor across all facilities and subcontractors. But the production line system meant that completed aircraft rolled out of the factory at intervals measured in hours, not days or weeks. At peak efficiency, a new Mustang was completed approximately every 2 hours throughout every working day. The scale and efficiency of this production system exceeded anything Germany had achieved, or given resource constraints and strategic circumstances, could reasonably hope to achieve. Messerschmitt and Focke-Wulf combined produced approximately 600 fighters per month in early 1944, despite operating under emergency priority programs, utilizing forced labor from concentration camps and occupied territories, and dispersing production across hundreds of small facilities to avoid concentrated bombing. German aircraft production could not match American output. The resource implications were equally sobering for German planners, who understood industrial capacity, determined strategic outcomes. American aluminum production in 1944 reached approximately 1.25 million tons, equivalent to £2.5 billion annually. This represented a massive increase from pre-war production of approximately 164,000 tons in 1939. The expansion had been achieved through massive government investment in new smelting facilities, improved access to bauxite ore from South American sources, and electricity generation capacity dedicated specifically to aluminum production. Germany's aluminum production, by contrast, peaked at approximately 250,000 tons per year and was declining steadily due to Allied bombing of production facilities and loss of bauxite sources in occupied territories. The Americans possessed approximately 10 times Germany's aluminum production capacity. This disparity was not merely numerical, it represented a fundamental strategic advantage that could not be overcome through tactical innovation or operational excellence. The decision to manufacture drop tanks from paper rather than aluminum was not driven by metal scarcity in the American industrial system. The United States had sufficient aluminum production capacity to manufacture every drop tank in metal if desired. Paper was chosen because it was cheaper per unit, required less critical manufacturing equipment that could be used for other purposes, freed aluminum for aircraft construction and other military applications, and could be produced more quickly with less skilled labor. This was industrial optimization driven by efficiency calculations, not desperate substitution driven by scarcity. The distinction was profoundly important. The psychological impact of these revelations spread systematically through the Luftwaffe technical and operational communities during the spring and summer of 1944. The paper drop tank became a symbol of American industrial capability and the fundamental disparity in resources between the combatants. Captured examples were displayed at technical briefings for Luftwaffe personnel transitioning to fighter operations. Pilots entering operational squadrons were shown the tanks and asked to calculate the tactical implications for combat operations. The message delivered was clear and deliberately unambiguous. American fighters could now escort bombers anywhere in Germany. The previous defensive strategy of waiting for Allied fighters to reach their fuel limits and turn back before attacking bomber formations was completely obsolete. Luftwaffe fighters would have to engage the escorts directly to reach the bombers, and those engagements would cost aircraft and pilots at rates Germany could not sustain given training, pipeline limitations and fuel shortages. Galland provided detailed operational assessments in conferences with senior Luftwaffe leadership throughout the spring of 1944. His conclusions were presented with the blunt directness characteristic of combat veterans who understood that sugarcoating strategic realities served no useful purpose. The P-51 was superior to German fighters above 20,000 feet. He emphasized repeatedly in official reports and personal meetings with senior commanders. It was faster than the Bf-109 at altitude and more maneuverable than the W-190 above 25,000 feet. With the extended range provided by drop tanks, it could escort bombers throughout their entire mission profile, from English bases to targets anywhere in Germany and back. German fighters could no longer attack bomber formations unopposed after Allied escorts reached their fuel limits and turned back toward England. That tactical window had closed, permanently. Every intercept mission now required fighting through the fighter screen first. Every engagement with American escorts cost aircraft and, more critically, experienced pilots. Loss rates were climbing steadily toward unsustainable levels. In January 1944, the Luftwaffe lost approximately 90-day fighters while claiming approximately 150 Allied aircraft destroyed. The exchange ratio appeared acceptable, though strategic analysis indicated the Allies could replace losses more rapidly than Germany. By February, German losses had increased to approximately 160 aircraft against approximately 230 Allied losses. The trend was clear and deeply troubling to commanders who understood the mathematics of attrition warfare. The Americans and British could replace losses faster than Germany could inflict them. German production capacity could not match Allied output. German pilot training programs could not replace experienced pilots lost in combat. The inevitable conclusion was evident to anyone willing to examine the data objectively. The summer of 1944 brought the full catastrophic impact of American Escort fighter capability to Luftwaffe day fighter units defending the Reich. The 8th Air Force conducted deep penetration raids almost daily when weather permitted operations. Mustangs provided continuous escort from English bases to targets across Germany and back. Luftwaffe fighter losses mounted at rates that could only be described as catastrophic. In June 1944, approximately 350-day fighters were lost, defending the Reich against American daylight bombing operations. In July, losses exceeded 350 single-engine fighters in the West alone, representing a 31.2% monthly attrition rate. August witnessed similar losses with a 36% attrition rate among operational fighter units. At these loss rates, experienced pilots were being killed faster than replacement pilots could complete training programs. The replacement pilots arriving from training schools had perhaps 150 hours of total flight time, compared to 300 hours or more for American pilots entering operational squadrons. Many German replacement pilots had as little as 30 hours in type before being assigned to operational squadrons facing combat against numerically superior forces. The experience gap, combined with numerical inferiority and the constant presence of P-51 escorts, made daylight operations over Germany increasingly deadly for Luftwaffe pilots. Survival became largely a matter of statistical probability rather than skill or courage. Galland submitted repeated assessments to Hitler and senior Wehrmacht leadership throughout this period. His September 1944 report stated the situation with brutal clarity, designed to penetrate the layers of denial and wishful thinking that characterized high-level strategic discussions. The Luftwaffe could not win the air war. Germany lacked the resources, the fuel production capacity, the aircraft manufacturing capability, and the trained pilots necessary to contest Allied air superiority. The Americans could replace losses faster than Germany could inflict them through combat operations. Their industrial capacity was beyond Germany's ability to counter through any combination of tactical innovation or operational excellence. The only viable strategy remaining was to husband scarce resources for defense of truly critical targets and hope for political settlement before complete military collapse. This was not defeatism. It was realistic assessment of strategic circumstances based on operational data. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945, scattered across the countryside like industrial confetti, marking the path of American bomber streams. German civilians learned to recognize the distinctive cylindrical shapes lying in fields and forests after air battles overhead. Initial reports sometimes described them as unexploded bombs, causing local panic until military authorities identified them as harmless fuel tanks. Instructions were distributed through civil defense organizations, explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons. Citizens were instructed to report their locations to local authorities, but not to approach them closely, as residual gasoline fumes could be flammable. The psychological impact was noted in civilian morale reports, compiled by various Reich agencies monitoring public sentiment. The sight of enemy aircraft overhead in such numbers that their contrails crisscrossed the sky, casually discarding expendable fuel tanks as they proceeded to bomb German cities, reinforced the increasingly obvious message that the Allies possessed resources to waste while Germany scraped desperately for every litre of aviation fuel and every kilogram of aluminum. Technical intelligence operations continued analyzing captured American equipment throughout 1944, but the focus shifted subtly from understanding capabilities, with an eye toward countering them, to simply documenting the scale of industrial disparity for the historical record. Could Germany manufacture similar paper drop tanks? The technical answer was unambiguously yes. German chemical industry could produce suitable resins using established industrial processes. German paper mills could manufacture kraft paper meeting the required specifications. The manufacturing process was not particularly sophisticated by German engineering standards, but the practical answer was equally unambiguous. No, Germany's chemical industry was already operating at maximum capacity, producing synthetic rubber to replace natural rubber supplies cut off by Allied naval blockade, explosives for munitions production, and other critical materials for military operations. Resin production for non-essential items like drop tanks could not be prioritized given competing demands. The paper industry was fully committed to military requirements for maps, documents, packaging materials, and bureaucratic necessities of administering a modern military fighting on multiple fronts. Most critically, there existed no operational requirement for extended-range drop tanks by late 1944. Fuel shortages were grounding large portions of the Luftwaffe as synthetic fuel production facilities came under sustained Allied bombing attack. Pilot training programs were reduced to minimal levels to conserve aviation fuel for operational missions. Operational sorties were limited by fuel availability rather than aircraft availability. Building drop tanks to extend aircraft range was operationally meaningless when there was barely enough fuel available for local defensive operations within German borders. The irony was stark and bitter to German planners, who understood resource allocation. The Americans had solved the fighter range problem with paper fuel tanks manufactured from abundant non-strategic materials at exactly the historical moment when German fighters were being grounded by fuel shortages resulting from systematic destruction of synthetic fuel production facilities. Different problems, different industrial bases, fundamentally different strategic circumstances, inevitable different outcomes. The Americans had more of everything that mattered strategically: more aircraft rolling off assembly lines every month, more aviation fuel pumped from oil fields or produced in refineries, more trained pilots completing flight schools, more aluminum smelted from bauxite ore, more industrial capacity available for military production, and sufficient excess capacity to optimize solutions like paper drop tanks rather than accepting whatever could be, produced from scarce strategic materials. Germany was fighting a war of scarcity against an enemy for whom scarcity was not a meaningful constraint. This fundamental asymmetry determined outcomes more decisively than any tactical innovation or operational excellence could overcome. By January 1945, the war's ultimate outcome was beyond any reasonable doubt for observers willing to examine strategic circumstances objectively. Soviet forces were approaching the Oder River, less than 50 miles from Berlin, advancing through territory Germany had no capacity to defend effectively. Western Allied forces had recovered from the Ardennes offensive and were pushing systematically toward the Rhine River, overwhelming German defensive positions through superior firepower and overwhelming numerical advantage. The Luftwaffe could mount only sporadic resistance, limited primarily by fuel availability and the catastrophic pilot losses sustained during 1944. The systematic study of American equipment continued at Rechlin, but it had become essentially an academic exercise. The findings were documented meticulously for the historical record, but they could no longer influence the war's outcome in any meaningful way. The final comprehensive analysis of the P-51 and its paper drop tanks was prepared in late January 1945 by technical staff, who understood their work served primarily documentary rather than operational purposes. The report documented every technical aspect of the Mustang's range capability that made it such an effective strategic weapon. The drop tank construction methods and materials were described in exhaustive detail. Production estimates were calculated based on intelligence assessments. Operational implications were analyzed with professional thoroughness. The conclusion was unambiguous and stated with characteristic German directness. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, had rendered the German heartland indefensible against American daylight bombing operations. Germany lacked the industrial capacity to match American fighter production at any sustainable ratio. Germany lacked the fuel production capability to sustain combat operations at the scale required for effective defense. Germany lacked the trained pilots necessary to replace losses at current attrition rates that showed no signs of declining. The report was filed in Reich Air Ministry archives in late January 1945. Whether senior leadership read it remains unknown. Documentary evidence is incomplete. By that point in the war, technical reports analyzing American capabilities were simply confirming what battlefield reality had already demonstrated beyond any possibility of denial. The Luftwaffe, which had dominated European skies in 1940 during the campaign in France and the Battle of Britain, was reduced to occasional desperate sorties by early 1945. Units hoarded precious aviation fuel for missions that could not change the strategic situation, but fulfilled the organizational imperative to resist, regardless of practical outcomes. American fighters roamed freely over Germany, attacking targets of opportunity, escorting bomber formations, strafing ground transportation, establishing complete air supremacy over territory that had once been defended by the world's most experienced fighter force. Each paper-drop tank falling from American aircraft represented a tangible reminder of the industrial disparity that had decided the air war more definitively than any air battle or technological innovation. The June 1944 exhibition at Rechlin had displayed captured Allied aircraft to Luftwaffe personnel, including multiple examples of equipment German pilots would face in combat. P-51 Mustangs were displayed alongside B-17 and B-24, heavy bombers, P-38 Lightnings, Lancaster bombers, Mosquito, fighter bombers, Typhoon fighter bombers, and various Spitfire variants representing the range of Allied air power. Thousands of Luftwaffe pilots and ground personnel toured the exhibition over several weeks, examining enemy equipment firsthand in circumstances far safer than combat encounters. The paper-drop tanks were displayed prominently with technical diagrams explaining their construction methods and range implications. The exhibition served simultaneously as educational tool and sobering reality check for personnel who might still harbor illusions about relative capabilities. German personnel could see directly the quality of Allied equipment, the standardization of components across different aircraft types, the evidence of massive production capacity, reflected in minor design variations between units that indicated continuous production runs, numbering in the thousands. The overwhelming scale of Allied industrial mobilization was made tangible and immediate through physical examples of equipment they faced in combat daily. The technical sophistication of the P-51 challenged and ultimately demolished carefully cultivated German assumptions about American engineering capabilities that had been reinforced through years of propaganda. Official information sources had portrayed Americans as capable of producing simple, rugged equipment in vast quantities, but fundamentally incapable of sophisticated design, requiring true engineering excellence. The Mustang demonstrated conclusively that American engineers could create highly refined, aerodynamically efficient designs that matched or exceeded German capabilities in the specific areas that mattered strategically for long-range fighter escort missions. The wing design represented advanced aerodynamic research, successfully implemented in high-volume production. The Packard V1650 Merlin engine demonstrated American capability to manufacture complex high-performance engines in large quantities with consistent quality. The aircraft systems integration reflected sophisticated engineering that successfully balanced multiple competing requirements. German pilots and engineers who examined the Mustang extensively could not honestly dismiss American engineering as crude or unsophisticated based on propaganda messaging. They experienced directly an aircraft that handled beautifully across its flight envelope, performed superbly in the mission profile that mattered strategically, and demonstrated thoughtful, competent design throughout every system they examined. The strategic air campaign over Germany succeeded largely because the P-51 Mustang's unique combination of capabilities made deep penetration raids operationally sustainable. Long-range bomber escort deep into Germany remained operationally infeasible until the Mustang arrived in substantial quantities during early 1944 and began flying operational missions protecting bomber formations throughout their mission profiles. Previous Allied escort fighters like the Republic P-47 Thunderbolt and Lockheed P-38 Lightning, despite considerable capabilities in other operational roles, possessed insufficient range to accompany heavy bombers to targets deep inside Germany and back to bases in England. This critical limitation allowed German fighters to wait until escorts reached their fuel limits and turned back before attacking bomber formations during the most dangerous portions of missions over heavily defended targets. The result was unsustainable bomber losses that forced temporary suspension of deep penetration raids into Germany during periods when loss rates exceeded 10% of attacking forces. The Mustang fundamentally transformed bomber escort operations by providing continuous, effective fighter coverage throughout entire missions, regardless of target distance from English bases. German fighters could no longer find extended periods when bombers flew without protective escorts that could intervene in attacks. This operational reality forced German pilots to engage American fighters directly, rather than simply attacking bombers, dramatically increasing the risk German pilots faced on every interception mission. Combined with growing Allied numerical superiority and declining German pilot quality due to reduced training time caused by fuel shortages, Mustang escorts made bomber operations over Germany operationally sustainable for the Allies, while German interception attempts became increasingly costly, ineffective, and ultimately futile. The broader historical significance of the P-51 and its paper-drop tanks extends well beyond their immediate tactical and operational impact during 1944 and 1945. They represent a compelling case study in industrial warfare and the decisive importance of production capacity in modern conflict between industrialized nations. World War II was decided not primarily on battlefields through tactical excellence, but in factories through productive capacity. The side that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies faster than they were consumed in combat operations held a decisive strategic advantage that tactical skill could not overcome. The United States achieved industrial mobilization on a scale unprecedented in human history. Peak wartime production in 1943 to 1944 saw American factories producing aircraft at rates exceeding 50,000 per year, Liberty ships at rates of multiple vessels per day, and ammunition in quantities measured in billions of rounds. This industrial output supported not only American military forces operating globally, but also supplied substantial quantities of equipment to Britain, the Soviet Union, and other Allied nations through Lend-Lease programs that provided war material without immediate payment requirements. Germany, despite possessing significant industrial capacity and world-class technical expertise, could not match Allied production output. The reasons were multiple and interconnected. Germany possessed a smaller industrial base than the combined Allied powers. Strategic bombing progressively destroyed production facilities faster than they could be rebuilt or relocated. Loss of occupied territories eliminated access to raw materials and forced labor sources. Resources were diverted to competing priorities that undermined overall military effectiveness. Inefficiencies in organization and planning reduced output below theoretical capacity. But perhaps most fundamentally, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. The addition of American industrial capacity to the Allied cause in 1942 to 1943 made Axis defeat inevitable once that industrial capacity reached full mobilization and began producing war material at maximum sustainable rates. Tanks falling across Germany in 1944 to 1945 symbolized this industrial reality in a form so simple and so stark that its message could not be misunderstood even by those who wished to deny uncomfortable strategic realities. The examination of captured American equipment by German technical intelligence services had been systematic and professionally competent throughout the war. Facilities like Rechlin maintained detailed records of performance testing, material analysis, and technical assessments compiled by experienced engineers who understood their subjects thoroughly. These documents, many of which survived the war in various archives, including the Bundesarchiv, provide valuable historical insight into how each side viewed the other's capabilities through the lens of technical analysis. German assessments of American equipment were generally accurate in technical terms for specific items examined. They correctly identified strengths and weaknesses of American aircraft, vehicles, and weapons based on systematic testing under controlled conditions. Where German analysis ultimately failed was not in understanding individual items, but in comprehending the full scale of American production capacity and the strategic implications of that scale for the war's ultimate outcome. A single P-51 Mustang was an excellent fighter aircraft with impressive performance characteristics. 10,000 P-51 Mustangs represented air superiority that no amount of tactical skill or technological innovation could overcome when defending against sustained operations by forces that could replace losses faster than they were inflicted. The story of German engineers examining paper drop tanks at Rechlin in March 1944 is ultimately a story about the fundamental nature of industrial warfare between modern industrialized nations. It demonstrates that in conflicts between powers with advanced industrial economies, production capacity becomes as strategically important as battlefield prowess or tactical excellence. The side that can build more equipment faster and more efficiently holds advantages that tactical and operational superiority cannot fully compensate for over extended periods of sustained combat. This lesson, learned at tremendous cost by Germany and Japan in World War II, influenced military planning throughout the Cold War that followed and continues to inform strategic thinking in the 21st century. The ability to sustain production of advanced weapons systems, to maintain supply chains under stress, to train personnel faster than they are lost in combat operations, and to outproduce opponents over extended periods remains as strategically critical now as it was in 1944, when German engineers first calculated the implications of paper drop tanks for the air war over Europe. Today, historians studying the air war over Europe recognize multiple interconnected factors that contributed to Allied victory rather than attributing success to any single technological or tactical element. Numerical superiority in aircraft and trained pilots provided quantitative advantages. Technological innovations in areas like radar, radio communications, and proximity fuses provided qualitative edges. Strategic bombing progressively degraded German industry and infrastructure. The cumulative effect of sustained combat operations depleted German resources faster than they could be replaced, given industrial capacity constraints. The P-51 Mustang and its paper drop tanks were important elements in this multifaceted campaign, but not the sole decisive factor in isolation from other developments. The air war was won through combined efforts of multiple fighter types, bomber forces conducting strategic campaigns, industrial production supporting sustained operations, pilot training programs producing qualified replacements, intelligence gathering, informing tactical decisions, continuous tactical innovation, and sustained commitment of resources over years of warfare. The paper drop tank represents one component of this larger effort, notable particularly because it so clearly symbolizes the industrial advantages that underlay Allied success across all dimensions of military operations. The technical files maintained at Rechlin documented American capabilities with professional precision, characteristic of German engineering culture. German engineers recorded specifications, performance data, construction methods, and production estimates with thoroughness that serves historical research decades later. These records, preserved in various archives, including collections in Germany and the United States, provide historians with detailed contemporary assessments of Allied equipment as evaluated through German technical analysis. Reading these documents today with the benefit of historical hindsight and access to American production records reveals that German technical analysis was largely accurate in understanding American capabilities. What they could not change through understanding was the strategic reality those capabilities represented. Understanding that an enemy possesses overwhelming advantages does not provide the means to counter those advantages when they are rooted in fundamental disparities of industrial capacity and resource availability that cannot be overcome through tactical innovation or operational excellence. The legacy of the paper drop tank extends beyond its specific wartime use to broader lessons about military innovation and industrial production. It serves as a reminder that effective solutions need not be technologically sophisticated or impressive by engineering standards. A fuel tank made from glued paper, designed for single use, manufactured from non-critical materials, represented an appropriate solution to the specific problem of extending fighter range for bomber escort missions. It was adequate for the operational purpose it served. This principle of designing solutions that meet requirements rather than pursuing technical perfection became a fundamental concept in modern systems engineering, applied to both military and civilian applications. The best solution is not always the most sophisticated or technologically impressive. The best solution is the one that meets operational requirements while being manufacturable in required quantities within available time, using accessible resources and production facilities. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.